And we're off. Okay, so first thing you might say this is requiring you to do is remember that slope formula. And you know, if you can like just think yourself through it, if you forget, oh, what's the letters, where, you know, rise over run, rises up and down, that's the y dimension. That's kind of the big deal, is to make sure you get your y values on top and your x values on the bottom. And then we're just kind of, you know, what's the difference between those two x values? And what's the difference? It means it's a subtraction problem. So if you kind of get messed up and forget what's what, you're subtracting the y from y and the x from x. Okay, so let's see. So call them two different points, just sort of generically. We say one is 0.1 and one is 0.2. Other important aspect here is if you start from a certain point for y, you have to start with that same point for x, right? If you mix them up, you're going to get exactly the opposite sign. You're going to get the wrong sign. All right, so the idea there, right? Doing your calculation. Being lazy. I'll do the big number minus the smaller number. I'll put 44 minus 36 on top. All right, so that's the first thing. Make sure you get the y's up there. And 9, then for x, minus a negative 7 is what I put up there, right? You're going to do the math now. And 44 minus 36 is an 8, right? 9 minus is plus. Minus is plus. 9 plus 7 is 16. And do reduce it, right? 1/2. Here. Not to get too messy, right? Slope of 1/2 from those 2 points. And as always, I'll count on you to jump in and wait a minute. Let me know if you have questions. Yeah. All right, over there, like I said, maybe you had trouble reading my graph. But at this point here, I said it was over at the x value of 2 and up at 10. Right? And that one over there, I'm trying to make it look like that was at 8 and up at 40. So if you can identify the coordinates of a couple of points, you know, look for spots where they really cross the lines. You really got to look at some of those lines in MOM, you know, look for ones that are clearly at the intersection of x and y lines. You know, make sure it's not a fraction value in between. But anyway, you could try to count your squares on your graph or otherwise come up with coordinates like this. So similarly here, right? My slope, the difference in the y's, the change in y, 40 minus 10, started 8 minus 2. And I think I got, what, 30 over 6. That's just 5. 5 over 1, would call it the integer 5. All right. Any problems? Any difficulties there? You might just answer for yourself, what's the intercept? There's only one intercept on that graph, right? That one special point, the origin, 0, 0. All right. Maybe this is like a revenue graph. A company makes $5 for every item, or they get $5 in revenue for every item they sell. They sell something for $5 per item, right? That's what the slope is. This might be an equation that just says the revenue is 5 times every x, right? 5 times every 1. What does it mean? What does the intercept mean then? 0. How many did I sell? 0. How much money did I make? 0. Okay. You don't sell any, you don't make any income, any revenue. All right, enough of that. A lot of times someone says, I have a quick question. Just kidding, that's totally good. If you do. All right, where am I? Where's my notes? All right, so slope intercept form. We're trying to see if we can get through 4.5, finish up this section. Slope intercept form. The particular shape of a linear equation that tells us the slope and tells us the y-intercept value. That form or kind of mold you use, mx plus b. Y is mx plus b. Could kind of try to do the explanation last time. Why is that b the intercept? Well, if I put in 0 for x, right? If I put in 0 for x, I'm on the y-axis someplace. Saw somebody say, oh, I get mixed up with my x and y intercepts. That's why I try to keep saying, it's the other one that's 0. Y-intercept, x is 0. X-intercept, y is 0. Okay. But if I put in 0 for x, y is the b value. So this number must be b, the y-intercept. And similarly, I realized maybe I didn't go through a real detailed explanation, but kind of try to point it out. As a result of looking at graphs, I could graph a line and sort of figure out what's the slope. And I just made that up. And if we were looking at the equation of a line, of that line, that 3/4 slope number would be this number right here, multiplying the x. How much do I modify that outcome value for each new additional x? You know, is it going up like my last one? Going up 5, going up 5. So what do we do with that? Well, we can graph a line if we know that information. All right, so I've got two very powerful pieces of information for this linear equation. If it's in this shape, I know its slope, specifically things mom asks you to be able to do. Look at that equation, what's the slope? Oh, there it is. It's multiplying the x, the slope is 3. What's the y-intercept? This one happens to be a negative intercept value. And like I say, I always kind of emphasize, yeah, that's when x is 0, we get a -4. I know a starting point. We kind of did this at the end of 4.4. Now I know a starting point on my graph, 1, 2, 3, 4, and I could use the slope to find a second point. Now, if it's 3, I always want to make that whole number or integer look like a fraction. So you're thinking change in y on top and change in x on the bottom. So 3/1 means if I go over 1, I'm going to go up 3. 1, 2, 3. So there would be a second point. Positive slope uphill. Whole number, you know, greater than 1. You know, bigger and bigger, bigger, steeper, steeper, steeper. Christina, oh, she must have fallen out. No, she's coming back. Good. So went through a couple of these last time. If you've got that shape information, right, got that form, then we can pull that information out and graph that line. And, oh, specifically, you know, got to think about, we're trying to use that slope to graph, right? Well, the slope here, again, it's in that shape. There's the y, mx plus b, right? It's in that shape. Pull out your slope value. And there's my y-intercept is 2, okay? But because it's negative, I have to decide to make one of those numbers positive and one of those negative. That overall negative fraction becomes the result of a plus-minus division problem like that. 0, 2, an intercept, starting point. This is saying if I go over 4, I'm going to go down 3. All right, so from the starting point, down over 4, 1, 2, 3, 4, down 3, 1, 2, 3. Second point, didn't ask me for the coordinates. I could find it if I wanted to. I missed it, but connect your dots. Okay. Just a couple let's just look at, again, I think I went over this last time, but you know, what's the slope there? You have to imply that one yourself, right? There's the slope of that one. Intercept of 5, we could use that to graph. Sometimes it's not in that shape, but we think it's going to be easiest to graph if we put it in that shape. So, you know, really it's arbitrary. We usually like to have the y first equals all that other stuff. So I'll do it that way, okay? Means I'm going to leave this y. You can kind of see how I could add the y and subtract the 6, and then it'd be all this stuff equals y. But I'm going to leave the y here and subtract the x's. So that leaves negative y, negative 2x, and the 6 that was still there, right? But this is the opposite of y, so I got to multiply both sides by negative 1. Really means do this, right? Got to distribute. So now I get it, multiplying by negative 1 flips all the signs. There we go. There would be that equation now. Doing some work to put it in slope-intercept form. Slope-intercept, that's why it's called that. Right? And now I could say, oh, I see my slope of 2 and my intercept of negative 6, and I could use that to graph. All right. I think I saw something in Mom. Oh, whoops, kind of like all mixed up. Let's see. Oh, graph that one. All right, here's where, let's get rid of fractions, okay? Here's where I am going to use, I'm not combining, this is x's, these are y's, this is a constant. I'm not just going to combine fractions, really. I want to rearrange this equation and put it in that shape. So I really am, or do need to use that technique presented somewhere in the last chapter where I multiply by a number that's big enough to get rid of all the fractions. Common denominator. What's the common denominator? I'm not going to build a common denominator. I'm going to multiply by this common multiple or common denominator. 3, 6, 2. A 6 would be the common denominator if I was trying to get all the same fractions. But I'm just going to multiply every term by 6. Okay, now I'm going to just multiply the numerator. This is like 6 over 1, right? So if I do that here, I'll write it all out. Well, hope you get it, right? Or I'm distributing to each piece. So that gives me 6 on top and 3 here. 6 on top, 6 over 2. I just showed what happens if I multiply the tops all by 6. Now I'm going to simplify. 2x minus y equals 3. Got rid of the fractions. So that was the point of that example, getting rid of the fractions. Now it's kind of like the one I did before where I probably would rearrange and put it into that shape. If that's good enough, I'll keep going though, okay? Yeah. Now this section of the text goes up, gets into some specific details that Mom never exactly covers. I do try to present all that stuff that's out of the usual content in the course, even if Mom doesn't throw it at you specifically. But there's sort of a set of problems there. Choose your favorite method of graphing. choose your best method to graph, right? Well, okay, here's a bunch of choices now. We can plot points, right? Remember just doing one of these things? Cumbersome, takes more time, annoying, whatever, right? Or if it's in this shape, now we know to use the slope and the intercept to graph it. What if it was in one of those, I'll put real numbers in here, okay? If it's in this shape and you have the option, right? Maybe I don't want to rearrange it and put it in mx plus b, but here's these two numbers work nicely with the 6. I might use the intercept method, right? So what do I have here? I have plotting points. Use slope and intercept. Find the intercepts. You can actually do that on this kind of equation too, but we're really kind of hoping that, gee, if I see one that looks like this, the easiest thing to do is start from the intercept and then use the slope for a second point. But I could use the intercepts. I could find the intercepts. I just made up one that'd be fractions, messy. Find the intercepts, remember that? Put in a 0 for the x and see what y goes with it. You have to solve for the y. Then do the other way around. Put in a 0 for the y and then solve for the x that has to go with it to make it true. That's finding the intercepts. Find those 2 points. And then sort of lastly, I'll just call them, how about those special ones? X equals 5. Y equals -2. There's a couple of special or weird, you might say, ones. Just ideally, you just got to remember what kind of line is that and where is it going? Excuse me. So here's where I try to drill, can you tell yourself that x is always 5? X is always 5. No matter what y is, x is always 5. Now I've run out of space. I can maybe squeeze it in up here. 1, 2, 3, 4, 5. X is always 5. Vertical line. All right. What's the slope of that line? Got to know that. All right. I know you don't all like to speak up, but that line is so steep.
-2.
Oops. I'm talking about this one. What's the slope of the, okay, this equation, x is always 5, is this line. That's all you, I think you were mixing up things. This equation is saying x is always 5. There's no y, no matter what y is, x is always going to be a 5.
And there is no slope.
Correct. We call it undefined.
Undefined.
Right, undefined slope. Now this one, yeah, undefined. Too many things on my board. I'll erase and start over in a minute. Undefined slope. And this other one, y equals -2. All right. Y is always -2. Y is always -2. Oh, okay, that's that one. No matter what x is, it's always -2. Horizontal line. Right. What's the slope of that one? This one we can actually say, oh, that is 0x minus 2. The slope is 0. And it goes away and we get y equals -2. But horizontal line, hopefully sort of intuitively, it's flat, no slope. Slope is 0. Okay. All right, enough of that. Well, then what else can we do with this form of the equation in particular? Oh, by the way, if you were looking at, I guess it'd be the first post in this week's forum messages. Thank you everybody for trying to post in the forum. It's just getting us to interact, and I really like what I see you folks doing with each other. But I posted basically an outline of all those different topics that we're kind of touching on in this chapter. And I suggested the first 10 we've actually sort of covered all the different graphing possibilities. That last one's kind of what I just did. For graphing, you have all these different choices, ways to graph. But we're going to keep working through the rest this week. All right, so get myself distracted here. All right. If I have two lines I happen to be looking at like this, what did I try to make look special about those two lines? Well, I tried to make them look parallel. What might those two lines, if they're parallel, have in common as far as their equation goes? What's the same about them? Right? Same slope. Parallel lines have the same slope. Well, we can use that feature to look at equations. Maybe I got some nice examples here. Right? There's a couple equations that represent two different lines. Maybe. I suppose it's possible. You have to actually be careful, especially when it's not clear what the slopes of both lines are, what the two equations are not in the same shape or form. So maybe they're the same line, right? They have to have the same slope and the same intercept, and then they'd be the same line. So that's a possibility. But we want to look at the slopes of these two lines and see if we can use that to determine whether these two lines are in fact parallel to each other. And of course, that always kind of gets hidden. You got to do some work to figure it out. Now this one, you can see the slope of that line in the equation, mx plus b, there's m, 2/5. This one's not in that shape. So we're going to put it in that form so that we can clearly see what the slope value is. So here we go again. I'm going to subtract those two x's. If I subtract the two x's, I get negative 5y is negative 2x plus 10. I'm going to try to squeeze it in one more line down there. Now I'll just go over here. See if that'll work, right? And now I'm going to divide everything by negative 5. Divide by negative 5, divide by negative 5, divide by negative 5, right? It's like parentheses, divide by negative 5. This one then gets me 1y equals negative is positive, 2/5 x. 10 divided by negative 5 is negative 2. All right, now it's in slope-intercept form. So parallel lines, we're going to do a similar kind of process in a second, different relationship. But you got to get them in this shape so you can look at the slopes and compare the slopes. So, oh, yeah, this one is 2/5 also. So yes, those two equations represented parallel lines. That's the deal there, right? Look at get them in the right shape so that you can find the slopes and compare them.
I'd appreciate it if you move just a tiny bit slower next time we do a problem kind of like this. I'm just really like copying down your work instead of like moving at your pace.
Absolutely, I understand, right?
I feel weird that I'm the only person that like really requests that, so I apologize to everyone.
Oh, please don't. I think I tried to make that clear in like one of my messages yesterday. Please ask your questions. You're almost never alone. There's always somebody.
Thank you.
Right?
You're not alone.
Anyway, so let's just do one of these again, all right? So, and here I'm going to say, and Are those two lines parallel? Well, maybe. Sure it is. He's making us do it. He must be. Ha ha ha. -3/4 is that slope that we can clearly see from the first one. You do some work. Can you rearrange that second one and put it in mx plus b shape? So folks just start saying, oh yeah, mx plus b, mx plus b. Why equals mx plus b? Slope intercept form. So that's what I'm talking about when I say that. Rearrange that one. Make you do the work for a second here. Can you rearrange that? Get just a little ahead. Go ahead. I did one step, subtracted the x's. Didn't really show it, just did it. Hoping we're getting good enough at that you understand. Yeah. But I have 8 y's, I need 1 y. I'm going to multiply both sides by 1/8 or divide every term by 8. -6/8 is -3/4 plus 2. Hopefully you got there. Now we can see this slope is -3/4, same as that one. So yes, those two equations represent parallel lines. In particular, notice this one had a y-intercept of 7. This one had a y-intercept of 2. So they are not the same line. They're two different places in the plane. So they're not the same. Okay. A similar relationship. That is a similar kind of thing we can figure out about two lines from the slope. Oh, I'm just going to eyeball a sketch here. And can you see what I'm trying to do there? If this was a right angle, right? Those two lines would be perpendicular. And it turns out there is a special relationship between the slopes of perpendicular lines. Couple of ways to figure this out. Negative or opposite reciprocals. Slopes are the opposite reciprocals of each other, or negative reciprocals. Sometimes when we use that term negative, everybody thinks, oh, it means it's got to be a negative number. No, negative means the opposite of. So if I have an equation, say it looks like this, a line perpendicular to that one has to have a slope that changes in two ways. That's what this is saying, right? Two differences between those slopes. They have to have opposite signs, and one is the upside down or the reciprocal of the other. So a line that had opposite sign of that one would be negative, and reciprocal would be 3/2. And then again, it doesn't matter whatever the intercept is, they're not going to be the same line. Those two lines would be perpendicular to each other due to the fact of that relationship between their slopes. Another way to describe that is if I was to multiply those two slopes together, say one is slope number 1. If I multiply it times slope number 2, they always kind of cancel but leaves the negative. You get -1, right? Like 2/3 times -3/2. right? If I multiply those two together, it looks a little messy. I'm sorry, you can't see my negative sign. All right? If I multiply those two together, 3's go away, 2's go away, but there's the -1. Usually it's just kind of easiest if you can recognize that they are opposite signs from each other and reciprocals of each other, then they are perpendicular. So you'll see mom problems, probably a test problem somewhere down the road that asks you, presents you with two equations, makes you do some work. Now, just like the parallel problems where I had to rearrange one of them, I had to do some work to see its slope, the perpendicular problems are going to be similar, right? You're going to have to do some work to see both of those slopes clearly. But the problems will ask you, are those two equations representing parallel or perpendicular or neither? There's nothing special about them. Parallel, they have to be the same. Perpendicular, they have to be opposite reciprocals. And if they're not one or the other of those, then they're just two different lines. Let's see, if I do this one, what's the slope of a line that's perpendicular to that one? So I put in an integer, a whole number in particular. What's the reciprocal? All right, this one has a slope of 2. The other one has to have a slope that's the opposite sign. What's the reciprocal of 2? You got to think of it as like 2/1. So reciprocal is 1/2. A line with that slope would be perpendicular. And we usually, all right? I usually do something like, oh, there's nothing special about, y equals 3/4 x plus 2 and y equals -3/4 x, but minus something. Now, opposite signs, but they're not reciprocals, right? So one's just kind of going up like this, positive, and the other one's kind of going like that, negative. Those aren't perpendicular, right? So it's got to, perpendicular lines have to include both of those distinctions, those differences. What's the equation of that line? Oh, I made my number too small. Let's go through a 4. What's the equation of that line? It's supposed to look horizontal. Something's always 4. Y is always 4. What kind of line is perpendicular to that one? What's perpendicular to horizontal? Vertical. So horizontal and vertical lines, just like the axes, right? Horizontal and vertical lines are perpendicular to each other. So if, let's see, 1, 2, 3, 4, 5, I'll say this is a 6 over here. What's the equation of that line? All right. All right. I'm giving you a slope value, and I gave you a kind of special point. What's the equation of a line that goes through that point and has that slope. That's what we're doing in 4.6. We're going to start trying to generate or create the equations ourselves. And we always need a slope and a point to work with, minimum, okay? You always need a point and a slope. What's special about that point? Where is that point? Where does that point live? Waiting on me, huh? What's special about that point? Oh, well, where is it? 0, 4, 0, 1, 2. Oh, why is that one special?
Is it because it's on the y-intercept?
Ta-da! Perfect. Yeah, that one's B. Okay? So if I get that point, I got it made. I know the slope and I know the y-intercept. What's the equation of that line? I'm done. Same thing. Do it again. What's the equation of that line? Oh, I see the 0 for x. That's what's got to go off in your mind. If x is 0, that's got to be the y-intercept. Maybe a problem will be really nice and say b is -2, but you got to get used to seeing it like this and try to make that association. Okay, I know the slope, I know the y-intercept. Ready, set, go. You know, write it down. You got it. Right. Ta-da. Find my notes here. Excuse me. Is that okay so far? So we're going to start, writing the equations, assuming that we can pull out the right information. It's always got to be a slope and a point. Well, what if it's not the point I want? Well, all right, here we go. Here's where it gets more work. What if I know a slope and a point that's not, let's see if I can make my life easier here if I make your life easier if I get some good numbers here. Let me switch those, okay? Sorry, folks. Got to go through this again just once to make sure, I'm trying to make nice numbers work out for you here. All right, so there are two processes that you can use. And whichever kind of looks like it's easiest for you, you can do it. All right, so first one, kind of a long explanation. How am I doing time? Okay. I'm going to take my slope formula. I'm going to show you where this another form comes from. Okay, we're not really in slope intercept form anymore. We're in writing equations, right? 4.6. Our slope formula, I'm going to turn it around so it looks backwards. Just kind of to see where, whoops, don't do that. This other formula comes from. All right, so that should just look like the slope formula except I switch sides, okay? Now, I'm gonna do a little multiplying, a little algebra to both sides of this equation. I'm gonna multiply both sides by the denominator. This is just show and tell, watch. I'm just sort of trying to show you where this new formula comes from. You know, you won't have to do all this stuff. But if I do that, this cancels out and just leaves this. All right? And I've got all that mess over there now. Ha ha. All right. Well, what does that do for us? Well, this is now almost one specific point. That is, oops, got myself thinking too many things at once. This is now a different form, almost the right form. And so look at the information I have, and what does this shape look like? Well, here's our two different y's and our two different x's, and here's the slope. What if I plug in what I know? Again, kind of walking it through here. We'll get more specific in a minute. Right, there's the slope number in that formula. Now here are the coordinates for one point. And I'm going to put them in for the x1, y1. And I'm just going to leave this other y blank. Notice the minus sign came with the formula, so it's minus this number, minus that number. Well, I plugged in the slope. I have the coordinates for a point in there, and here's the x and the y that my formula usually has. Don't need the little subscripts anymore. This now is what's called, if I take away those extra numbers there, point slope form. And you might look at that, it's like, oh my gosh, look at all those different pieces I have to keep track of. That's why there's a second technique that some folks like better. We'll do that in a minute. I think time. But this form here is called point slope form. If I know one point, not the intercept, and I know the slope, I can plug in the slope value in that formula and the coordinates of the one point I know. It's always minus the coordinate. So if it was a negative number, it'd be minus minus, we'd see a plus. It always looks like it's opposite the point, the coordinates you know. So let me clean this up a little and just use it. Now the issue is that's where we start, but the problems will almost always then require you to rearrange that mess and finish up by putting it in that shape to finish as your final answer. So if I know a slope and I know a point, I can write the equation for that line by using the point slope form. There's that form. Okay, I can write the equation for that line by plugging in the coordinates, make sure you get your x's and y's in the right place, right? And the slope. So here's my y that I'm going to put up there. Y minus 4 equals slope 1/2 parentheses. That 1/2 has to distribute if you simplify. X minus 2. That now is an equation of the line. The next step is to rearrange. The last process is we have to rearrange it and put it in this shape to finish. So that means a little extra work here. Distribute. Haven't done anything here yet. 1/2 x, 1/2 times -2, a -1. All right. Funny looking 2, sorry. And finally, got to add this 5 here. I'm thinking ahead, right? Got to add this 4 here to both sides. It won't be a 5 anyway, will it? 1/2 x looks like +3. So there would be the equation of the line with that slope going through that point, final version in slope-intercept form. Okay. Y value, X value, and the slope. The extra work usually is annoying, you know, more chances to mess something up because you have to do this distributing and moving things around. Because of that, folks sometimes like this other method. All right, here I go. I've got a couple minutes left, and this is where we'll pick up tomorrow. Really, I'm a little bit ahead, which is good because then it leaves us more time for word problems to practice them and stuff like that. Right? Review on Thursday, test next Monday. Okay, let's do it a different way. Let's say I know a slope, easy numbers here, and at this point. Okay, well, I'm going to do a technique that we call solve for B. Find the B so that I can use this shape right from the start. Different technique. So basically we're going to use slope-intercept form and plug in what I know. This is a X value and this is a Y value that have to work in this particular line, right? But I don't know what the B value is. But if I plug that stuff in, if I put in a 4 for the Y, right, equals slope times 9 for the X. There I did, I got myself a good number. But plus B. See, I got a formula now. The only thing I don't know is B. I don't know. So I just simplify and solve for B. 1, 3. Subtract the 6. -2 is my y-intercept. The B value is -2. Now I have to go back and use the slope I started with, and now I know the y-intercept and write the equation. But not negative. Let's see, 2/3 x minus 2. So a lot of folks think that's less messy, a little easier than the point slope form. Okay. Now I probably scared you all with that at the end today, but we're out of time at 10:50 today right now. So we'll come back tomorrow and pick up right here and do several more. We have more work to do with writing equations, figure out how to write equations if we have the right information. Okay, but if you're trying to work ahead, you could get a start. Yeah, get a start in 4.6. All right, yes, folks. Well, you guys enjoy that beautiful weather if you can, if you get to. It's supposed to be like this most of the week, I think. So
Yep.
that means I have to go work in my yard.
Done.
All right. Well, have a good day, and I'll see you tomorrow.
Have a
Okay.
great day. Take care. Bye.
Bye.